3. It is acids, bases, and salts. Lesson number 3, acids, bases, and salts. So here already we have something knowledge about acids, bases, and salts from the previous classes from your 7th class especially. In that, we have learned about 3 substances with their nature. So what the 3 substances? Acidic substances, basic substances, and neutral substances. Here, that nature of the substance will be decided by us based on the taste and maybe based on the indication, right? So here, based on nature, that substances are classified mainly into 3 categories, namely into 3 categories. What they are here? One is here acid substance, basic substance, or maybe the neutral substance. Acidic substance, basic substance, and the other substance is neutral substance. So here now, according to the taste, as we learned in the 7th class, what is the taste of acidic substance here? That substances which are sour in taste. Sour in taste, that substances here named as acids. If the substances maybe or they are bitter in taste, or we can say one more observation here, soapy to touch, slippery in nature, slips, right? So bitter in taste or soapy to touch, they are here called as bases. Then what about the neutrals? Actually, there is no particular taste to give about that neutral substances, right? So here simply we have 3 categories of substances. One is acid, base, and the neutral. Sour in taste, that is said to be here acid. If it is bitter in taste, base, or also one more observation here about the bases, slips, that is given as here slippery in nature, soapy to touch. Then neutral substances, no particular taste. So 3 categories. For them, we have many examples from day-to-day life based on the taste only here. Acidic taste, sour taste, fruits, or some eatable items. For example, here lemon water or lemon juice, tamarind, orange, grapes. So many are there. We can write many examples for acids here. Then bases, which are said to be here bases, bitter in taste. So here in our day-to-day life, we can eat many substances which are bitter in taste, like cucumber, bitter gourd, red gourd, etc. So these are, we can give example for bases. Then what about salts? No particular taste. No particular taste. So here simply we have examples for the neutral substances without any taste. Distilled water. Distilled water, no taste. Actually pure water has no taste. Common salt. From our day-to-day life, we can give 2 examples. Common salt to distilled water. So here my question is this a right way to find out the nature of the substances? You are deciding the nature of the substance based on the taste. So is it the right method to decide the nature of the substance? No. Why not? Here it is maybe sometimes harmful because we don't know the nature of the substance. We don't know that maybe is it a harmful substance or good. If it is maybe poisonous nature, so what do? Nothing. If you taste, suppose cyanide, if you taste poison, it kills. So here it is not the right way to test the nature of the substance by the taste. So we have to search for another method. We have to search for another method. How do we? Right? So here it is harmful method. So we decided here how to find the nature of the substance other than tasting. So here using the indicator, we can find out the nature. Using the indicator, we can find out the nature. So what is an indicator here? Do you know what is an indicator? Here, indicator is nothing. It is indicating us. It is indicating us, giving some indications, indicators, right? Identifying the change. So something it can change and it can give you simply some change, indication. By using that, you are able to know about the substance nature as acidic, basic, or neutral. So here indicator meaning is simple. The substance which shows the acidic or basic or neutral behavior, whatever it may be. Three types of natures. The nature of the substance may be acidic, basic, or the neutral. That can be indicated by a substance by changing its color. So something it can change its behavior in different substances, either acidic or basic or maybe neutral also. It indicate that substance behavior by changing its color. So that we can call it as indicator. So what are indicators here actually? They are maybe itself. It is a weak acid or maybe a weak base. Indicator itself, it is a substance, either weak acid or a weak base. It can change its own color in different mediums. Acidic medium, basic medium, or neutral medium. Right? So what is an indicator means? What we have to write? What we have to write? Indicator itself, it is a weak substance, weak acidic substance or weak basic substance that which can change its own color in different substances. So that is enough. Then here we have types of indicators. What are the types of indicators here? What are the types of indicators here? So here, based on the preparation or based on the availability or from which source you are collecting them, then we can classify them as followed here. So here there are maybe natural indicators, maybe olfactory indicators, or maybe synthetic indicators, or maybe here they are universal indicator, right? So these are the types of indicators. How many got? 4 types: natural, olfactory, synthetic, universal. So universal means for all, everywhere, right? So here natural indicators, olfactory indicators, synthetic indicators also called as laboratory or artificial. Synthetic indicators are also called as laboratory or artificial indicators. Universal indicator. So these are the types of indicators. So individually we can discuss now. Which are said to be here natural indicators, or which indicators are called as here natural indicators? Simple, natural. So from the nature. So naturally they are available. You are preparing that indicators using natural sources. The indicators which are obtained from the natural sources are called natural sources. Obtained from natural sources are called natural indicators. Example for the natural indicators are here: litmus paper, turmeric powder, red cabbage juice that we can prepare from the China rose also. That is nothing but hibiscus. Right? So these already we learned in our 7th class. Acids and bases, second lesson of 7th class. Right? So turmeric, litmus, red cabbage, China rose, beetroot, mango leaves. Right? So many examples are there that we can use as indicators here. They are called as here natural indicators. These are olfactory indicators also called as natural indicators because these are also from the natural sources, right? Indicators that which are changing their smell, odor, changing their smell, what we can call as odor. So this is called olfactory indicators. So that which can indicate us the nature of the substance by changing its smell. Indicator smell changes. So what are indicators available here as olfactory indicators? There are 3 substances mainly we discuss in our lesson. They are here: onions, vanilla essence, and clove oil. 3 we will discuss: onions, vanilla essence, and clove oil. So these are the 3 substances. These are the 3 substances used as olfactory indicators. Olfactory indicators are nothing that indication by changing its smell. That substance is called here olfactory indicator. Olfactory indicator. So simply we have learned about olfactory indicators. Next, here we will go for another one, that is here synthetic indicators. That are what here? Synthetic indicators, also called as laboratory or artificial indicators. So indicators simply synthetic. It is a process, synthesized, processed using different substances. So the indicator, it is a substance. So that you are preparing using some different substances, maybe chemicals or natural sources. So that are synthesized, called laboratory indicators. So we can synthesize them in the laboratory. So they are called here synthetic indicators, right? Example for the synthetic indicators or for the laboratory indicators are here 2 there. They are namely here. One is methyl orange and the other is phenolphthalein indicator. One is methyl orange and the other is phenolphthalein indicators. So here simply these 2 are called as laboratory indicators. Next here, universal indicator. So indicator named as universal. So everywhere for any substance will be useful. That indicator is called here universal, all purpose simply. It is also useful to find out the strength of the acid or the base. Also useful to find out the strength of the acid or maybe the base, called universal indicator. 3 natures you are able to find out, and also with the nature you are able to know the strength. So indicators used to find out the strength as well as nature. So that indicator called here universal indicator. Example for the universal indicator is pH paper. pH paper is called as universal indicator, right? So here simply we are dealing 3 types in our subject. So what they are namely here, the 3 are here simply litmus papers, methyl orange, and phenolphthalein. These 3 we are dealing in our subject. So here litmus paper, they are available in 2 colors. They are available in 2 colors. What they are here? One is blue colored litmus paper and the other is red colored litmus paper. So blue colored litmus paper. So like this they are available here as you see on the screen. So this is I displayed on the screen is blue colored litmus paper. Then one more color is available, that is red litmus paper, as you see on the screen. These are prepared or obtained from lichen. That is actually pronunciation is lichen, right? So that is belongs to Phenolphthalein division. Biologically, it is belongs to Phenolphthalein division, right? So here from that you are separating the pigment, a liquid that is separated and used as a dye on the paper. So that we can call it as litmus paper. It is clearly given in your textbook in the introduction page as a box at the bottom. So look at them in your textbooks. So here available in two colors, ice blue litmus paper and red litmus paper. So here we have advantage with this litmus papers. Blue changes into red and red changes into blue or remains maybe in same its own color, right? So here if blue litmus changes into red in color, red litmus changes into blue in color, we have differences. Here in the first beaker, I dipped blue litmus paper. See here, up to what portion you immersed or introduced into the liquid substance, that is changed into red color. So blue changed into red, that I can call it as here blue changed into red. So that indicating us as here acid. The nature of the substance is what? Acid. Blue litmus changed to red in color. It indicates the nature of the substance as acidic nature. Then see the second beaker. I introduced red litmus paper. So red changed into blue in color. That indicating the nature of the substance as basic nature. So look at that. First beaker has acid. Second beaker has base. Sir, if I noticed no change in the color of any litmus paper, blue remained as blue, red remained as red, then it is neutral. Look at that. I am using here solution, litmus solution. Look at the change in the color of the test tubes. What happened? See here. When I add litmus solution, first beaker changing into red color. Look at the second litmus solution changing into blue in color. So this is indicating us acid and base. Acids always affects the litmus paper blue into red. So finally red color, that is acidic medium. If it is remain in blue color, sorry, it changes into blue color, that is indicating ice basic substance, right? So here this you have to understand. So here simply we have an idea about litmus solutions, right? I think everyone you got an idea about this one, litmus papers and litmus solution. Give me your impression, please. Quick impression, thumb impression, if it is clear to you, everyone. Yes, very good. So now we'll go for another. Simply here about another indicator is methyl orange. So how it is, where is available, synthesized, laboratory. So we will get it from the lab. What is the color of methyl orange? Red orange or orange, or you sometimes you may call as yellow orange also. So red orange maximum, orange in color. So look at on the screen. I'm giving you methyl orange color on the screen. So it is available like this. Then here this methyl orange we are using to find out the acidic nature or maybe the basic nature or maybe the neutral substances using methyl orange. So that methyl orange we can use to find out the acidic nature. Suppose if you add that methyl orange into the acidic medium, it changes into red color, indicating the nature of the substance as acidic. So methyl orange turns to red color, then it is indicating the nature of the substance as acidic. Methyl orange turns to yellow. If it is changes into yellow in color, then it is indicating the nature of the substance as basic. So two colors. Methyl orange, own color is red orange, and it changes to dark red called acidic substance. If it changes into yellow color, that substance is called as basic. If it remains in its own color, that orange or red orange, then it is said to be neutral. So here simply look at that. In acidic medium, red color. In basic medium, basic also called as alkaline, right? We'll discuss about what is alkaline later. So here simply methyl orange, own color is red orange or yellowish orange. Then it changes into red color, that is acidic medium. It changes into yellow color, it is called as basic medium. Remains as same, no change in its methyl orange own color, then it is neutral. So are you clear about this one? Go to quick impression, please. Are you clear about this? Yes. Then now about phenolphthalein indicator. So actually phenolphthalein itself, it is colorless. In acidic medium or maybe in the neutral substances, it remains colorless, as like your water color. Phenolphthalein itself, it is colorless solution. So remains colorless for acidic substances, also for neutral substances. Remains colorless for acidic substances and also for neutral substances. It changes its color only into pink color. It changes its color only into pink color, that is in basic medium. That is in basic medium. So if phenolphthalein turns into pink color, then it is indicating the nature of the substance as basic substance. So this is about indicators. Are you clear about these things? Give me your quick impression, please. I gave you information about simply 3 indicators. Namely, they are what here? Litmus papers, methyl orange, phenolphthalein. All these 3 together are useful to find out the nature of the given substances. What they are? Acidic, basic and neutral substances nature will be decided by using the following indicators: litmus papers, methyl orange and phenolphthalein. So these are we are using in our classrooms to find out the nature of substances. Now about activity 1. So introduction of the lesson is completed. In your textbook, there is an activity 1, that is to find out or to know the nature of the substances that which we are collecting from the laboratory, right? So here simply response of various substances or laboratory substances with these indicators we are now learning. Response of various laboratory substances with indicators. So how they can affect the indicator? Suppose if I take phenolphthalein, it changes into pink color. So which is affecting the color of phenolphthalein into pink color? That is basic substances. So nature of the substance will affect the indicator. So indicator is what? The substance which can change its color in different mediums. That is called an indicator. Indicator itself a weak base or a weak acidic substance. So here we are making a table. So here in the table, now we are writing the columns as following here. So the first one is serial number. Then the next one is sample solution, what you are collecting from the laboratory. So laboratory substance is given as here sample. Then using the red litmus paper, blue litmus paper, then phenolphthalein indicator and methyl orange indicator. So these we already learned in the previous discussion. Red litmus changes to blue color, basic substance. Blue litmus changes to red in color, acidic substance. Phenolphthalein remains colorless, maybe acidic or neutral. Methyl orange changes into red, it is acid. Or yellow, base, if it remains in its own color, neutral. So that observations already we made, we observed clearly. So using them, we can decide the nature of the substance of the following. So here simply I am going to collect that substances from the laboratory, or so that can be named as here sample solution. The first one is HCl. Next I am going to collect H2SO4. Next I am going to collect here nitric acid HNO3. Next acetic acid CH3COOH. Next sodium hydroxide, caustic soda, also called as caustic soda, that is NaOH. Next KOH, potassium hydroxide. Next magnesium hydroxide, MgOH2. Next I am going to collect, it is ammonium hydroxide, and finally it is calcium hydroxide, CaOH. So these are the laboratory substances you are collecting from the laboratory. Hydrochloric acid, sulfuric acid, nitric acid, acetic acid, caustic soda, potassium hydroxide, magnesium hydroxide, ammonium hydroxide, and lime water, are also called as lime water only, right? Also called as here calcium hydroxide. So these are the substances you are collecting from laboratory. Then using the indicators one by one. Suppose all the substances are collected. Suppose if I am using to know the nature of these solutions using only red litmus. So I'm going to introduce that red litmus into the HCl. Then observing the color of that litmus paper, red litmus remains red in color in HCl. So what you can decide? Is it maybe acid or the neutral or the base? So if it is acid, red litmus paper does not affect, or maybe the neutral, red litmus paper does not affected. If it is maybe the basic, that red litmus changes to blue. So what I am going to observe here, red remains as red. So we can write our observation as no change in the color. No change in the color. Then next, dipping that red litmus paper into the sulfuric acid or H2SO4. So in this also, red litmus paper does not affected. So no change. Nitric acid HNO3 does not affect the red litmus paper. Acetic acid does not affect red litmus paper. Then that same red litmus paper introducing into the caustic soda, sodium hydroxide. Then I am going to notice that red litmus paper changes into blue color. Then noticed. Then red litmus paper into potassium hydroxide, also observing that is changing into blue color. Next, magnesium hydroxide, introduce that red litmus paper, also observing changing into blue color. Next, ammonium hydroxide, same red litmus paper introducing into the ammonium hydroxide, observing blue color. Calcium hydroxide, blue color. So these are the observations with the red litmus paper among these sample solutions. Next, I am changing that litmus paper with blue now. So using blue litmus paper, introduce that blue litmus paper into HCl solution. Now I am going to observe that blue color changing into red color. Blue litmus paper, introduced into the HCl solution and noticed that blue litmus changed into the red litmus color. Then again take a new blue litmus paper, introduce into sulfuric acid. Again you will notice that changes into red color. Take blue litmus paper, introduce into nitric acid. Again I will notice that changes into red color. In acetic acid, red color. Now blue litmus into sodium hydroxide, no change. In potassium hydroxide, no change. In ammonium hydroxide, magnesium hydroxide, no change. In ammonium hydroxide, no change. Into the calcium hydroxide, no change. So here, litmus test completed. Red litmus changes into blue color, basic nature. Blue litmus changes into red color, acidic nature. So already I decided the nature with the litmus papers. So what about HCl here? Acidic. What about sulfuric here? Basic. What about HNO3 here? Acidic. HCl, acidic. H2SO4, acidic. Acetic acid, acidic, because they are affecting the blue litmus paper, changing the color of blue into red, acidic. Now, look at the remaining. Effect on red litmus paper into blue color, right? Blue base, BB. So here, blue color, basic. So sodium hydroxide, potassium hydroxide, magnesium hydroxide, ammonium hydroxide, and calcium hydroxide, all these are bases. The next, using the phenolphthalein solution and adding 2-3 drops of phenolphthalein solution into sulfuric acid, hydrochloric acid, no effect, no change in the color, so remains colorless or remains in the same color of that particular substance solution, but no change into pink, right? So here sulfuric acid also remains colorless, nitric acid colorless, acetic acid colorless. Sodium hydroxide, phenolphthalein indicator, when you add, it changes into pink color. Potassium hydroxide, effect on phenolphthalein, pink. Magnesium hydroxide, pink. Ammonium hydroxide, pink. And calcium hydroxide, pink. So phenolphthalein gives pink color only in basic medium, remains colorless in acidic solutions and also in the neutral solutions. So we cannot decide the nature of the substance as acidic or the neutral using phenolphthalein. Carefully, I am unable to decide using the phenolphthalein as nature of the substance either acidic or neutral. Contradiction. Remains colorless in the both. So that's why I am able to decide only basic solutions using phenolphthalein. Next, methyl orange in HCl changes to red. In sulfuric acid changes to red. In nitric acid changes to red. In acetic acid changes to red. Methyl orange turns into red color only in acidic medium. Next, in the bases, that is sodium hydroxide, potassium hydroxide, magnesium hydroxide, ammonium hydroxide, and calcium hydroxide. They affect the methyl orange, changes its color into yellow color. So yellow bases. So these are the observations. So this is observation from the activity 1. You can fill the table by taking the screenshot in your textbooks. So make it a screenshot. Make it a screenshot. Right? So this is about activity 1. I think everyone clear about this activity and observations, what you are going to observe when you conduct this activity. Give me your response, please.